Hello, everybody, and welcome to Mr. Saucedo's YouTube videos. Today, we're going to be looking at how the Earth has changed over time. So we're going to start way back. 4.5 billion years ago is approximately when the Earth formed, along with the rest of the solar system. So you can see the layers of the Earth here. The heavier elements, like iron and nickel, sank and formed the core. The lighter elements, like silicon and magnesium, rose to form the liquid layer that we call the mantle. Okay? And so there's magma, by the way. As the magma layer reached the coldness of space, so think about this, right? You have this gigantic, basically molten sphere that is extremely hot, like super hot, for probably, millions or hundreds of millions of years. The surface of the Earth is just this magma, superheated mess. Eventually, though, right, there's no atmosphere. And so the coolness of space is going to start to solidify the outer layer of the Earth, which we call the crust. So you can see that. There's ground on. You can see that here, right? So we've got our inner core and outer core made primarily of iron and nickel. The mantle is all that would have probably been visible. There would have been no crust right when the Earth formed. And so that's mostly made up, like it says, silicon and magnesium. And then eventually, after, a very long period of time, the crust begins to form as a lithosphere, a solid rocky exterior starts to form. Now, keep in mind, the center of the Earth is still extremely hot today, and it is residual heat from the formation of the Earth. So the reason why we have a molten interior on the inside of the Earth is because it's still hot today. It's been 4.5 billion years, and the core is still extremely hot. And keep in mind, right, that the Earth's magnetic field does come from the movement of that liquid iron in our outer core. And that is very serendipitous, right? Because the magnetic field does help to protect us from a lot of dangerous solar radiation. And there you go, there's magneton. The crust cooled over the course of, again, who knows how long, but it probably did not cool evenly. That means that it would have broken or cracked. I picture it kind of like, like if you're baking bread, you'll see as the dough is solidifying and forming that crust on the outside, little pockets of hot steam and stuff will poke and pop out of the bread. And so you get this unevenness. We're not entirely sure when plates formed. Um, I know that there are ideas that, they formed within the first, this is going to sound, again, because we're talking about billions of years. And so it makes it sound like, oh, yeah, it's so recent. But 3 billion years ago or something like that, right? That the plates were probably um, uh, in a process of continual subduction, um, and they didn't resemble probably exactly the plates of today, but still, at least we know that plates did form. And now keep in mind, right, that denser plates are made out of oceanic crust, while lighter plates form the continental crust. So the continents meaning the land that we actually are currently standing on. So just keep in mind that there are two varieties of plates. The oceanic crust is a lot denser. It is what, all of the oceans like the Pacific and Atlantic and Indian Oceans and Antarctic Oceans, all that stuff, right? All of those oceans are situated on top of that dense oceanic crust, whereas the land that forms, the actual continents themselves is a lot lighter. And so that's the stuff that we are standing on right now. And that's it for today. So if you have any questions, let me know.